By the binomial theorem of the zeta function, the subordinate zeta functions 6, 1 and 6, 5 located on the critical line can be obtained, and the zeta function and the L function of mod 6 can be derived by the subordinate zeta functions 6, 1 and 6, 5. The sum of the subordinate zeta functions 6, 1 and 6, 5 is the zeta function of 1 minus 2 to the minus s power and 1 minus 3 to the minus s power excluding divisors 2 and 3 of 6, and the difference of the subordinate zeta functions 6, 1 and 6, 5 is the L function chi1 of mod 6. The subordinate zeta function can be obtained by the binomial theorem of the zeta function, and it directly corresponds to the zeta function and the L function. It is analytically the same as the Hurwitz zeta function, but considering the relation with the subordinate eta function, it is represented as the subordinate zeta function for consistency. When calculating the subordinate zeta function 6, 1 and 6, 5 up to 100 terms of the zeta function, they are identical to the 13 decimal place of the Hurwitz zeta function, 1 over 6 and 5 over 6 at s equals 1/2, and they show an error of more than 8 decimal places even when the imaginary part a increases. If the red subordinate zeta function 6, 1 and the blue subordinate zeta function 6, 5 are equal to each other, they are trivial zeros of the L function chi1 of mod 6. In addition, if the red subordinate zeta function 6, 1 and the blue subordinate zeta function 6, 5 are symmetrical to the origin, they are non-trivial zeros of the zeta function with opposite signs, of which the imaginary parts a are 14.1, 26.0, 25.0, and etc. The subordinate zeta functions 6, 1 and 6, 5 do not have zeros even when they go up along the critical line, and they are not symmetrical to each other. However, the symmetry of the subordinate zeta function 6, 1 and 6, 5 makes non-trivial zeros. The numerator and denominator of the gamma function of the binomial coefficient can be expressed as a product, but the binomial coefficient of the gamma function disappears when the zeta function and the L function are inverted. Therefore, the L function can be expanded again into the negative zeta function and represented as a symmetry by trigonometric functions. Although the inversion of the zeta function and the L function does not prove the Riemann hypothesis, the proof of the Riemann hypothesis may ultimately be finding and proving the symmetry of the zeta function.